So in this problem, we are given the equation of a parabola. We need to determine the coordinates of the vertex and the focus, equation of its axis and directrix, as well as the length of the lattice rectum. Let us begin. So what we'll do, we are going to start with the given equation of the parabola and try to write it in its standard form. So here we have 4y squared minus 20y plus 12x plus 67 equals to 0. We'll keep the first two terms and transpose the third and the fourth term to the right hand side, and that's going to give us 4y squared minus 20y equals to negative 12x minus 67. Now let's take 4 as the common factor. So we have 4 times y squared minus 5y equals to negative 12x minus 67. We're going to divide both sides with 4 to give us y squared minus 5y equals to, so negative 12x divided by 4, that will be negative 3x, and we have negative 67 over 4. Now we'll try to make y squared minus 5y into a perfect square. For this, we're going to manipulate the second term. We're going to rewrite it as 2 times y times 5 over 2. Now 5 over 2, we can take the square of that value, 5 over 2. And then this is an extra term we are adding, so we're going to subtract 5 over 2 whole squared from it. That will be equals to negative 3x minus 67 over 4. Let's further simplify. Now, the first 3 terms is nothing but the expansion of y minus 5 over 2 whole squared. Now, that will be equals to, now we can transpose negative 5 over 2 whole squared to the right hand side. So that will become 25 over 4. And we already have negative 67 over 4 on the right hand side minus 3x. So this will be y minus 5 over 2 whole square equals to, so 25 over 4 minus 67 over 4, that's going to be negative 21 over 2 minus 3x. We're going to take negative 3 as the common factor. We have y minus 5 over 2 whole square. So that will be equals to, if we take negative 3 as the common factor, we have x plus 7 over 2. Fine. Now what we'll do, we're going to make a, we're going to label this as number 1, and we're going to make a substitution here. So let y minus 5 over 2, that does be equals to y in uppercase, and x plus 7 over 2 equals to x in uppercase. Then equation number 1 is going to now become y squared minus 3x. So this is comparable to the standard form. So the standard form will be y squared equals to minus 4ax. So here we take the standard form, y squared equals to negative 4ax. So this is going to be the standard form of a parabola. Standard form of the parabola. Now for this particular parabola, if we compare, then we get negative 4a equals to negative 3. Which means that a value comes out to be 3 over 4. We're going to use this value. We'll come back to this in a moment. Now, we'll consider this particular parabola. Now, we know that for parabola given by y squared equals to negative 4ax, its vertex of the parabola is going to be always at the origin, 0, 0. Now, this particular vertex corresponds to x, y. Fine. But we have considered x to be equivalent to x plus 7 over 2. So here if we compare, so we are going to get x equals to 0 and y equals to 0. And we have since considered x to be equivalent to x plus 7 over 2. So this will be equals to 0. And in place of y, we take y minus 5 over 2 equals to 0. So here, if we solve this, we get the values of x and y. So x will be negative 7 over 2. And the value of y comes out to be 5 over 2. So that means the coordinates of the vertex of the parabola, that's going to be negative 7 over 2, positive 5 over 2. Okay, so we're done with the vertex. Now, for the parabola given in the standard form, y squared equals to negative 4ax, what is the coordinates of the focus? Now, clearly, this is a left-facing parabola. So its coordinates will be, we know the coordinates given in terms of the coordinate axis x and y will be given by negative a comma 0. Now in our case a is 3 over 4, so that means the coordinates of the focus will be negative 3 over 4 comma 0. Now here what we can do, we can equate x with negative 3 over 4 and the value of y will be equals to 0. Now since we have already considered x to be x plus 7 over 2, so we have x plus 7 over 2 that will be equals to negative 3 over 4, and we have y minus 5 over 2 that will be equals to 0. So let's solve for the value of x. X will be equals to minus 17 over 4, and the value of y will be equals to 5 over 2, which means that the coordinate of the focus will be negative 17 over 4 comma 5 over 2. Now we'll try to find out the equation of the axis. We know that the equation of the axis of the parabola y squared equals to negative 4ax. This has the equation which is the x-axis itself. That means its equation will be y equals to 0. Now we have chosen the value of the uppercase y as y minus 5 over 2. That will be equals to 0. So that means y will be equals to 5 over 2, and this is going to be the equation of the axis. Then we have the equation of the directrix. The equation of the directrix of y squared equals to negative 4ax. Now since this is a left facing parabola, its equation will be given by x equals to positive a. Now a, that's 3 over 4, so that means x will be equals to 3 over 4. However, we have chosen x to be equals to x plus 7 over 2. So the a becomes equals to 3 over 4. Solving for x, we get x equals to, we have 3 over 4 minus 7 over 2. We'll get negative 11 over 4. This is going to be the equation of the directrix. And finally, we'll find out the length of the latus rectum. The length of the latus rectum of the parabola, that's simply given by the absolute value of 4 times a. So here a, that corresponds to 3 over 4 or 3/4, which means that the length of the latus rectum will be 3 units. So here we have successfully obtained the coordinates of the vertex, the coordinates of the focus, and then we have the equation of the axis, the equation of the directrix, and the length of the latus rectum. So to give you a context of the problem, so what we did, we were given the equation of this particular parabola. The equation of this parabola was given to us. So what we did, we tried to rewrite it in the form y squared equals to negative 4ax, which told us that this particular parabola is a left-facing parabola and which vertex at the origin. So that's why here we have considered the coordinates axis x and y in the uppercase. But we also use the transformation. That means when we shift the origin from O to O prime, then in that case the shift was following x minus x plus 7 over 2 equals to x and y minus 5 over 2 equals to y. So that's why our vertex has shifted to negative 7 over 2 comma 5 over 2. This is how we are easily able to obtain the focus of the parabola, the vertex of the parabola, the equation of the directrix, the axis of the parabola, including the length of the latus rectum.